Hello, for a short video on the Monte Carlo Module 3, just to catch everyone up after a quiz, after a guest speaker, several excused absences. I thought it might be good just to go over Module 3 and get us all on the same page. In Module 3, I've got the video list that continues to grow. Recently added one there on forecasting prices using a random walk, I believe it was. And then I had a couple of class exercises, different versions with solutions. I've replaced those with class exercise September 30 with solutions. So I'm going to go ahead and delete these, leaving you with a good study file for the quiz here. And then if you weren't in that class, I had assigned the September 30 exercise to go ahead and submit that, just to make sure that everyone had seen that material. And then October 5th, I posted an exercise, and for my Wednesday classes, I posted it and called it 5th and 7th. So I'm going to go ahead and remove these because they've been replaced with this class exercises, October 5 and 7, with solutions. Another good file to study for the exam. I also posted a file today based on some of my 10-minute team progress reports. It's called If and Ifs for discrete outcomes. I encourage you to take a look at this file because it talks about something a little bit different than we've been doing. Most of the time when we talk about sampling a random input, we're sampling from a normal distribution. But many of you have, let's say, the presidential election or some other binary outcome on your models, and you needed to know how to do that. Well, one way to do that is to use an if statement and say if some random number is less than some threshold, then maybe candidate A wins, otherwise candidate B wins. And so you can work through this AB exercise with an AB solution and figure out how to do that. I also put in an ABC. This is a relatively new function in Excel. It's called IFS, or ifs. And the way ifs works is instead of saying if one thing is true, then do something, otherwise we would normally nest in another if statement. So if candidate A didn't win, let's see if candidate B won or if candidate C won. Well, ifs is a handy way to look at all those. And a good way to look at these functions is to hit Shift F3 and bring up the function editor. Another way to get there is this little FX button. And so what it says is, well, let's do a logical test. Let's say if the random number was less than the, what was a candidate 1 choice? Candidate A had a 40% chance. If the random number was less than 40%, then candidate A wins. If not, let's keep looking. Well, what if the random number were less than the 40% chance of A and the 30% chance of B? Well, if we got that far, then candidate B wins. Well, if neither one of those happen, let's go test something else. And eventually you get down to the last thing that you want to test, and you ought to just set it to true to guarantee that it happens. And then that leaves you with the final choice, candidate C. Here are some study questions. This is what I'd like you to get out of this file. So look over that before the quiz. Back to Canvas. Those were the if and ifs practice file. Another file I put in here is a convergence example. Some of the teams were asking me, well, how many iterations do we need to run our model for? In class, we usually do 100. I've heard you talk about 500. How many should we do? So let's open up the convergence example and see what it says. I want you to work through this example, read through what it says, and think about these questions. But what we're doing here is we've got a candidate A, candidate B situation again. Candidate A's got a 50% chance of winning. So how many iterations do I need to run before I can average them and feel pretty comfortable that 50% is the result of that? Well, it's easy if I know going in that 50% is the result. But if I don't know what the result is, like NPV on my model or the chance of my final wealth amount meeting a certain target, I don't know what the answer is. So I don't know when I get there. So I need to guess about how many iterations to run for that model to converge. So what this one does, if I hit F2 on this, it says count up the number of times that candidate A has won so far, and then divide by the iterations that we have, and that gives us the percentage so far. So in the first three, if we just ran 3 iterations, we'd say candidate B or candidate A had 0% chance of winning. If we went ahead and ran 4 iterations, we'd say, well, candidate A had a 25% chance of winning. The more iterations we run, the more this thing converges toward the 50% that we know is the correct answer because that's what we put in. And so this is a chart, and it's actually a semilog chart, so we can get a whole lot of iterations on here, but we see it in scales, orders of magnitude of 10. That's what a semilog chart is. And it says, well, the first 3, it looks like candidate A has no chance. But after you run about 10, then candidate A starts getting up around that 50%. After 100, it's actually further from the truth. After 5,000 of these things, it looks like we're leveling off around 20%. We call that convergence on a Monte Carlo model. And so when you're running your models and you're trying to figure out what is the actual NPV I should be getting after a number of iterations, you could make one of these charts. I'll probably require it on the final model submission to show me how did your NPV converge over numbers of iterations. If I come up here and hit F9 and rerun the simulation, it looks totally different. The first 2 iterations, candidate B lost, but then candidate A won the next 5. And so early on, it looks like, well, maybe candidate A has a higher chance of winning than 50%. But sure enough, if you run thousands of iterations, eventually it levels off around that 50%. So the question is this: how many do I need to run? Well, say 10,000, then I'll always get it to converge. Different models, depending on how complicated they are, may converge more quickly or may take more iterations. So my question for you is this: how many do you think you would need to feel comfortable with the results? How would that change if each iteration cost you 1 penny, cost you $100 to run 10,000 iterations? How would it change if each iteration cost you 1 second? It might take you 15 minutes or so to run several thousand iterations. Is that really worth the time? So think about that as you're doing your group models. Let's get back to Canvas. The final thing I want to post for you before the OU Texas weekend is this Monte Carlo simulation notes. And this is for anyone who feels like, well, we didn't get PowerPoint slides, we didn't get a textbook to read about this stuff. Can you at least give us a brief overview? So I've come in here and written up a brief introduction to Monte Carlo. It's got the Investopedia link that I know many of you have taken the time to look at. It's got a little bit of terminology on here. I may add convergence to this terminology before I post it. It talks a little bit about the uncertainty distributions from which we're pulling our random samples, how we estimate the inputs to those, specifically the normal distribution, the 68, 95, 99 rule. Talks about unbounded distributions, and does it really make sense to sample from a normal distribution that could be infinitely positive or infinitely negative? In practice, it probably doesn't. In this class, we'll take some shortcuts, but on the formula list that I'll show you in a moment, we've got the actual equations that are much more complex. The data on a blank cell method, I feel like the class is coming along pretty well on that so far, but here's a brief overview for that. In this course, I'm not going to talk about how to correlate inputs. So if tax rates go up, perhaps we'd expect interest rates to go up somewhat. Maybe not in step with them, but maybe they should trend together. So if it's completely uncorrelated, I talk about using different instances of RAND. A good example for this would be if we're forecasting returns each year for an asset. We don't want them to be correlated perfectly. We don't want them to, in fact, in this course, we're not correlating them at all. But we'd like them to be independent. So maybe one year we have a good year in the stock market, maybe one year we have a bad year in the stock market. You can read more about uncorrelated inputs here. On the other hand, sometimes we want our inputs to be correlated. And in this case, we talk about how to correlate them perfectly by referring them both to the same instance of RAND. There are a couple of other things on the formula sheet. For example, the ifs that I went through earlier in this video needs to look at the same instance of RAND. That's a pretty fundamental idea for this part of the course. And then finally, the analysis of results. We've done it in class. You've followed along well. You haven't seen a real list of what we want to do. So what I want you to be able to do by quiz 3 is use the frequency Now, someone asked a great question. What about Excel's data analysis add-in that makes histograms for us? It gives us the same answer, but it doesn't automatically update itself. And so that's why I like to use the frequency function to do my own frequency charts, own histograms. COUNTIF is one that we used a little bit. Percentile and percent rank are other ones that we use. So read through this. The two charts that I care about for this is the histogram chart, which is based on that frequency function, and the cumulative probability distribution, which is ultimately based on the percentile function. And then in the last week, I've been going over working with chart series. If you were excused from an absence this week, you probably need to get with me on chart series. We've covered some pretty good tips on that I'm not going to repeat in this video, but essentially how to work with individual series, how to work with the series formula that shows up in the formula bar, and how to work with the entire chart in terms of adding or removing series when they're adjacent. And then finally, applications, just a few words about that. And finally, the formula sheet, which I will bold. And I will probably tweak this a little bit before the quiz, but you'll have plenty of chance to work with it before the quiz. So I hope this video has been helpful to give you just a really quick overview of what we've done so far in Monte Carlo. The next thing you'll see from me is the assignment, which is due on October 18th, which is your final model submission. Have a great weekend if I'm not going to see you in your team progress report tomorrow, and Boomer Sooner, beat Texas.